Solving rational equations. Method 1. You can change each term to a common denominator and cross out all denominators because you understand that we're multiplying both sides by the denominator, of course. And let's do that with this case. So if you look in the denominator, we have 3n and we also have 3n. All right, so we want to try to make all the denominators 3n. That means that for the first one, we're missing an n in the denominator. So therefore, we should also multiply by n in the numerator. Essentially, we are multiplying this fraction by 1. The next part is missing a 3 in the denominator. And so we also need a 3 in the numerator. Don't forget the parentheses. And the last part already has 3n, so we're good. Okay, next, we're going to have to distribute the numerator here. And we end up with 4n divided by 3n plus 3n plus 21, all divided by 3n. And that is equal to, the right side stays the same. All right, now next, as you can see there, we're going to multiply both sides by 3n. Now, this is what I'm going to do. I'm going to just cross out the denominator, but that is with the understanding that this is what I'm really doing. Okay, and here's the explanation. So that leaves me with 4n plus 3n plus 21 equals 3n plus 1. And now I can subtract 3n from both sides. That gets rid of this. I'm left with 4n plus 21 equals 1. Subtract 21, divide by 4. We get that n equals -5. Now we should check that to verify. So we saw there's the work. Always check back into the original equation. And because we get a check mark, it verifies that this indeed is the solution, n equals -5. So that was the first method. The second method to solve rational equations is to multiply both sides by the least common denominator. All right, so we have 3, we have an n, we have a 3n here. So I'm going to make a line here. My scrap work is going to be on the right side. I recognize that my least common denominator is 3n, 3 times n. So therefore, I'm going to multiply both sides by 3n. Again, you see the parentheses there. It might be easier if you do all the pieces, all the multiplication on the right side. So for example, if I'm multiplying 3n times 4/3, I could do that part on the right side. So I see there that the 3's will cancel out, and I get 4n over 1, but I don't need the over 1. All right, the next part, now I'm going to multiply 3n by the next term. There it is. I wrote it as 3n over 1, just so that way I have fractions. Here, the n cancels out, so then I have to multiply 3 times n plus 7, and that leaves me with 3n plus 21. And last, multiply 3n by the right side. Here's what that looks like. That's a little bit easy because 3n and 3n, those factors, they cancel out. Again, canceling out means that 3n divided by 3n is 1. And all we're left with is 3n plus 1. So I'm going to summarize all that right here. This is what our pieces were. And similar to the other example, I could subtract 3n from both sides. That just cancels those out. Subtract 21, divide by 4, and we get n equals -5, which we verified earlier is true. Solve this rational equation. You can see it's a little bit more complicated. Worth noting here is that we have a quadratic in the denominator, and we also have a minus. All right. Things to keep in mind: there may be extraneous solutions. So that's an apparent solution that must be rejected because it does not satisfy the original equation. Okay, first thing I recognize is that if I was to factor the denominator here, that's a difference of two squares, I would have x minus 3, x plus 3. And luckily those factors occur in all the other parts. So therefore, that's my least common denominator. So I'm going to multiply, I could either multiply both sides by that least common denominator, or I can change it so that all the denominators are the same. And I'm going to go with that second choice. All right, so notice that I have the left side factored. I'm going to erase this just so that it's easier to see. Okay, the second term here. So we have x plus 3 already. So we have this. We need x minus 3. So x minus 3. And I'm also putting that in the numerator because don't forget, essentially, this number is we're multiplying that fraction by 1, which makes it a legal move. Okay, the other one, we have x minus 3. So we have the x minus 3. We're missing the x plus 3. Okay. So now at this point, because all my denominators are the same, I am just going to cross them out. But again, what I'm really doing is multiplying by this amount. This way, I find it makes it easier for people to see all the pieces. All right, what are we left with? We have 8x squared minus 4x, parenthesis x minus 3, close parenthesis, equal, and then 6 times the sum of x plus 3. All right, we can do that. We can distribute everything, combine the like terms. 8x squared minus 4x squared gives us 4x squared. Subtract the 6x, subtract the 18, bring everything to both sides because we have a quadratic equation. And to make it easier, why not divide by 2? If all those numbers are even, I can divide by 2, and I'm left with 2x squared plus 3x minus 9. I could solve that many different ways. I could factor, I could complete the square, quadratic formula. I'm going to factor, I'm going to use grouping or bust B. So if I multiply the first two terms, 2 times negative 9, sorry, the a and the c coefficient, that gives me negative 18. And I'm looking for two numbers that multiply to negative 18, but they have to add up to 3. And those two numbers would be 6 and 3 in some way, but because it has to be a negative 18, that would make the 3 negative. So then I'm going to just bust that 3x into a positive 6x and a negative 3x. I'm going to group the terms. Notice here that I have a plus, and then I'm going to factor out the greatest common factor from each of the grouped terms, and that gives us, notice that it's color coded. Now the way I got that step is you're doing distribution in reverse. So it's the distributive property, and if we were to distribute what I have up here, I would end up with what I have down here. Let's move on. So we have two factors. We can apply the zero product property. So we know that 2x minus 3 equals 0, or x plus 3 equals 0. All All right, add 3, divide by 2, we get that x equals 3/2. And on the right side, we get x equals -3. Now the -3, if I was to substitute in the original equation, I would have -3 squared minus 9. So I would have 0 in the denominator, which makes x equals -3 an extraneous solution. So we can't have that. Now we have to check x equals 3/2. So here's what that looks like with substitution. You can use a calculator, but don't let your other skills get rusty. I just want to show you the right side. So on the right side, I would have 9/2 minus, so 3 could be written as 6/2. Which would give me 6 divided by -3/2. And I have 6 divided by that number, or I can multiply the reciprocal. And if you understand this little move, so 6 times 2 is 12, and 1 times -3 is -3. I mean, that's the same as multiplying the reciprocal. I get -4 on the right side, and if you do the left side and work it out on your own, you also get -4. That's a check mark, which verifies that x equals 3/2, or 1.5, is our solution.